Welcome back. We are creating, we are doing integrals with U substitution. And there are times that I call this an all-out U substitution. And whenever we have to actually do this, is when we have an extra x. Because if I changed, if I changed this square root to be a blob to what? A blob to the 1/2. But I'm looking at that blob, y'all, what is this? What is the derivative of it? It's just a plain 2. Right here, whenever we have an extra x, we got problems. So my just thinking in terms of blobs does not work. So we have to do an all-out U substitution. And whatever is in, the biggest blob or whatever, that has to be our U. So 2x minus 1 is our U. We have no choice. But we have an extra x and we have a dx. So what I'm going to tell you to do is solve for the x. What would I need to do to solve for x? Add 1. Divide by 2. Or multiply by 1/2, right? Would that be 1/2 u plus 1/2 if I distributed it? And therefore, what would dx be now? Do y'all remember just the one little section on differentials? The differential of x is 1/2 times the differential of u, or du, if I probably would have had just done, what would du dx be here? 2, and therefore du is actually 2 dx, or dx is 1/2 du, right?
Wait, so how did you find du over dx equals 2?
I just took the derivative here, du dx, the derivative of u with respect to x.
Oh, okay.
Is just the 2, and then divide by 2, and you'll have dx is du over 2. But the way we did it in that chapter 4 was just take the differential of x and take the derivative of this and throw in a du, right? Differential of u. It's always the same thing. Are we good? Do you prefer to think of it this way, or to go from just taking the derivative and then solving for the dx? 2 different ways.
I'll probably find out as we go along.
All right, so now we're going to do an all-out U substitution. It was our u. Everybody agree? U to the 1/2. I solved for x, so I'm going to replace x with 1/2 u plus 1/2. Everybody agree? And the dx, I solved for it, and it is 1/2 du. So now I'm changing everything that had an x in it into a u. Question?
Where did the other 1/2 go to get 1/2 du?
Where did it go?
Yeah, because it's 1/2. Oh, it's okay.
Yeah, it's a coefficient in like the derivative for the du. Thank you. So now, there's a couple things going on here. I'm feeling like, what can come out of these two? A 1/2. And I'm left with a u plus 1. I don't have to do this step. I was just thinking 1/2 times 1/2 is just a constant, right? What can I do with those constants? 1/4 and take it to the outside, right? And then what can I do? Distribute. U to the 1/2 times u to the 1. plus distribute. Any questions so far?
No.
And now, keep the 1/4 out. And notice, this is something I noticed on your quiz, terminology, you're keeping the integral mark a little too long. Once we add 1 to the power, which is adding 2/2, right? Dividing by the new power, dividing by 2/5, dividing by 5/2 is multiplying by 2/5. Add 1 to that. 3/2, dividing by 3/2 is multiplying by 2/3. What I was saying is I'm seeing a little too much. Once we take the integral, no longer have the integral mark. Now, you might say we're done, but we did start out with what's? X's. We have to go back, and it's just a simple resubstitution. I'm going to go ahead and distribute because 2 cancels with the 4 to leave it 1/10. 2x minus 1 to the 5/2. Distribute here, 2 cancels with 4 to leave a 2 times 3 would be 1/6.
This is foul.
It is what it is.
It is what it is. It is an all-out U substitution.
Oh my gosh.
Now, there is one slightly different light on definite integrals with an all-out U substitution.
You just give up. Maybe for you.
Listen, if you multiply everything by 0, you always get a good answer.
Put less
So
than or
multiply
equal
your
to
grade
it.
by
then
0.
So, guys, somebody tell me, where do we get these limits of integration? What values are these?
The endpoints A and B.
The endpoints A and B, which are X values, right?
Yeah.
These are, so if I wanted to remind myself, this is from X equals 1 to X equals 5, right?
Yes.
So the same thought process, in fact, it's actually the same blob, isn't it? Let's make it, oh, I'm just going to keep it 2x. So my blob is, or my U is 2x minus 1, right? Because this is actually 2x minus 1 to what power?
Negative.
Negative 1/2. So the same process, solve for x, or if you want to do du right here, is 2 dx. So what is dx equal to? Du over 2, or 1/2 du, right? Solve for x, we get u plus 1 over 2, just like we did a second ago. So, so our x goes from 1 to 5. So guess what? If we're doing an all-out u sub, I'm going all-out u's. If x is 1, what is u? 2 times 1 is 2.
minus 1 is 4.
Oh, so u is 1 when x is 1. If x is 5, 5 times 2 is
10 minus 1.
10 minus 1 would be
9.
9. So now we actually never, if it's a definite integral, the one beauty of an all-out U sub is that you don't have to go back to x's. We can stick with u's. So this will be u to what power?
Negative 1/2.
The x should be u plus 1 over 2.
I'm assuming these will be calculator, right?
These will not be calculator, because otherwise you just plug it on the calculator, math 9, and be done.
Should it not be DU?
Shouldn't it be
Oh, du, good call. Wait,
1/2?
du, it should be 1/2 du, because it was dx, and dx is 1/2 du. Thank you so much.
Show your shirt.
All right,
Silly goose.
so we have 1/2, we have another 1/2 here, so we still have that 1/4, right? I'm still rewriting, because now I don't have a product rule, so I'll have to distribute. What's u to the negative 1/2? And by the way, you'll see how I got 1/2 times 1/2 is 1/4. So these are taken care of, right? Distribute u to the negative 1/2 times u to the first is plus u to what? Negative 1/2. Took care of the 1/2. Yet again, the terminology here, all that I've done so far is rewriting. I still have not integrated. But now I am integrating. Add 1 to the power. Divide by 3/2 is multiplying by 2/3. Add 1 to this one. Dividing by 1/2 is multiplying by 2/1. If we're going to free response it, which we're welcome to practice that for AP, 2/3 times 9 to the 3/2 plus 2 times 9 to the 1/2 minus, use parentheses. Do not forget these parentheses. You will not get your answer correct. 2/3 times 1 to any power is 1. So there would be your free response answer. Could this be a multiple choice though?
Yes.
Absolutely. Because what is the square root of 9? 3. 3 cubed is 2/3 times 27 will be a nice easy number. That's just the square root of 9. 3 times 2. Minus 2/3, distribute the negative, minus 2. 3 goes into 20. Well, let's just leave it because we have a third right here. 6 minus 2 is 4. 27 times 2 is 54 over 3 minus 2 over 3.
52 over?
52.
Is that Transformers? Oh my god, is that Transformers?
Now, 4 is actually, oh, sorry, I'm not off the screen. 4 is actually 12/3, right? Plus 52 would be 64.
So we can just leave it in that free response way and not.
If this is a free response question, stop here. There are way too many places for mistakes. If it is a multiple choice answer, this will most likely not be your answer. So you have to be able to do a little bit of math. 16/3. So, could we check this on our handy dandy calculator? Yes. Will this be a calculator problem? No. Not for me and probably not for AP.
Well, they should.
Integral 1 to 5. Alpha y equals x over square root of 2x minus 1
Don't look at me like that, I'm sleepy.
dx. 5.3 repeating. 16/3. Yay. You got it right. Now, so not all of them will be this weird and hard to plug in, but that is the general idea. You want to do one trig one?
We're definitely okay. You should, yeah, you should just give us some, please. We get it. No.
You might agree.
This one
I think we
is,
need to have a conversation.
this one is a rich problem.
They're the same guys who write fart dog on them.
This is a rich problem here, the way it's written.
Mr. Moneybags up there.
What?
We coming up
You're not just.
YouTube video.
Oh my God.
Guys, this is going on for social media.
I love YouTubers.
If we do this, is this a legal step?
Yes.
Yeah, and by the way, whether we're thinking this or not, u cubed plus u, what is the derivative of our u? If u is sine of x,
Cosine of x.
oh my goodness, there it is, du is complete, check it off. What do I do to these u's to powers? Power up, divide by the new power. Oops, and don't change the limits of integration to pi over 4. Now, we're dealing with sines and we're dealing with pi's over 2. That was actually pretty nice because
So it's 1.
it's going to be 1 or negative 1, right? Pi over 2, if you look at the sine curve, the y value is 1. So 1 to the 4th is still 1.
Plus 1/2
1 squared is also 1. Then we're going to subtract.
minus -1.
Negative pi over 2 is just a y value of negative 1, right? But negative 1 to the 4th is,
Oh, 1, so.
uh-oh,
0. So 0.
Good job.
Which makes sense when you look at the sine curve.
I mean, if we're just doing a straight sine curve, the area above the x-axis will definitely cancel out the area below. But, you know, we're multiplying a sine cubed by the by the cosine of x, and a sine other than, these are still odd powers, aren't they? Odd powers, odd functions probably have that symmetry with respect to the origin, so. I didn't see it from the start, but I will say, if I give you negative 99 to positive 99 of the regular sine of x dx, do you know what your answer will always be?
0.
If this is an odd function, and those are the same number, the area above will always cancel with the area below. If you had to prove it, you could say, because y equals sine of x is odd. And as long as that is, you know. Now, cosine wouldn't work so easily, but if I had like negative pi over 4 to pi over 4 for the cosine of x, it will be different. However, couldn't you split this up and say this would be 2 times 0 to pi over 4? Because cosine is an even function, so the area to the right of 0 would be the same as the area to the left of 0 as long as these numbers matched. So this would just be a little thing to make it slightly easier. But you will get the same answer both ways. That would be the only shortcut you could use for the cosine. But for odd ones, it's kind of nice. I actually think I taught the whole chapter, the whole section. Yeah.
Wait, that's it?
Extra time?
One more